Hello, 6th grade. Today we are going to look at lesson 16.5, which is to describe distributions. So your objective today is students will be able to describe the shape, distribution, and range of a data set and use the shape, measures of center, or variability to draw conclusions about the data. So let's look at step it out. Number 1. A veterinarian monitored 18 pregnant cats. The number of kittens per litter is summarized in the table. What statistical question might these data have been collected to answer? All right, so we are looking at how many kittens are in a cat's litter. All right, so since the table shows exact data values, and as you can see down here, you can see that we're going to use a dot plot is a good choice to display the data. Plot the data on the dot plot. All right, so we need to look at this. So this means frequency of this number. So we have 1, 1. We have 3, 2, so 1, 2, 3. We have 4, 3, so 1, 2, 3, 4. We have 3 4s. We have 3 5s. We have 2 6s. We have 1 7. We have 0 8s, and we have 1 9. So that is what that dot plot should look like. So describe the shape, the distribution, and the range of the data. So because of this outlier here, we're going to say that the graph is not symmetric. So not symmetrical. Okay, there is a cluster, and that is between 2 and 5. So as you can see, most of the data range between those numbers. So between 2 and 5. Once again, there is a gap between what? 7 and 9. So gap at 8. And the last thing it asked us was the range. So the range is the difference between that largest and smallest. So 9 minus 1. So the range is also 8. All right, so then it asks us to find the mean, the median, and the mode of the data. Round to the nearest tenth place is necessary. So that means we have to, excuse me, write all these out and then add them together. So 1, 2, 2, 3, 3. I think I missed a 3, didn't I? Yep. And then 4, 4, 4, 5, 5, 5, 6, 6, 7, and 9. All right, so when we add all those together, the mean would be 74 divided by 18. So when we divide that, we get 4 1/10. The mode is the number that occurs the most. So as you can see, we have 4 3s. So that would be 3. And the median, so if we line them up, it's going to be somewhere in this 4. So somewhere here, I think. So 1, 2, 3, 4, 5, 6, 7. We'll say 8. And then 1, 2, 3, 4, 5, 6, 7, 8. Yep, so right there. So the median is 4. All right, so looking at the shape of the data distribution in the dot plot, which of these measures of center would best represent the data? Explain your reasoning. So because of this outlier, because of the 9 way up here, we know that it affects the mean. So we are going to say, so the mode would be better. Okay. And some of you may have said the median, but they're so close together though. But the mode represents the data that is presented down here the most. So we're going to say mode. All right. So turn and talk. Explain why the mode is the best measure of center for the data. So they kind of told you the answer here. So the reason why is because the cluster is near the mode. So if it's between 2, the cluster was between 2 and 5, right? But we have more data points around that 2 and 3, so that's why the mode is the best. All right. Number 2. So it says the table shows the distance some students at Valley Middle School live from the shopping mall. What statistical question might these data have been collected to answer? So it says students live from the school. So how far students live from school. All right, so we're going to finish this histogram. So they told us that's the best value, right? All right, so between 4, can't see that, and 1/10 and 6, I'm sorry, 100th is 6. So we're going to go back up here. Remember, we're going to take it right off of that other side. All right, so 6, between 6 and 100th and 8 is 9. So we're going to start from here. So 8 is going to be in the middle. All right, 8 and 100th between 10 is 8. So once again, that's going to go here. 10 and 100th and 12 is 5. So off of here in the middle. And between 12 and 100th and 14 is 1. So that is right there. All right, so that is what that dot plot should look like. You could color it in if you want, but doesn't necessarily have to be colored in. All right, so describe the shape, center, the range, and the distribution of the data. So we're going to say the shape looks pretty symmetrical, right? This one's pretty, these two right here are pretty close. This one's pretty close. So we're going to say it is symmetrical. Okay, so it is symmetrical. We have no outliers. There are no gaps. And it looks like the peak is between 6 and 100ths and 8. And then it asks us, what about the range? So the range is, the largest value is 9 and the smallest value is 1. So the range on this one is 8. Okay? All right, so draw one conclusion about the survey results based on the fact from part C. So we can say people, if you want to say students. Okay, so people that live between 6 and 100ths and 8 is almost the same as 8 and 100ths to 10. Because this one was 9, this one was 8, so very close together there. All right, so let's look at that turn and talk. Suppose that there were 15 students missing from the sample. 7 students lived between 2 and 100ths and 4 miles from the mall. 3 students lived 4 and 105 miles from the mall, and 5 students live between 10 and 12 from the mall. How might your summary statement change? All right, well, let's look at that. So I'm going to try to use a different color and see if you can, I guess, see the difference. I don't know. We'll see, because it's kind of dark. All right, so how many? So 7 students live between 2 and 4. So that means if we already have 4, we're going to now be at 11. So it's going to go here, right? Maybe if I color it in, we can see the difference. Okay, and then 3 students live between 4. So if this adds 6, it's going to now be at 9. And 5 students live between 10 and 12. So this is already at 5. That's going to put me at 10. Okay, so hopefully you can see our peak has changed, right? It's no longer symmetrical. So let's write that down. So no longer symmetrical. Okay, peak is at 2 and 104. Now we can say that most people live, I would say most people live between 2 and 104, because that's where that peak is. Okay? All right. So let's move to 3. 3 says the table shows the average daily temperature in degrees Fahrenheit during Maria's 8-day family vacation. Since the table shows distinct data values that have a wide range of values and gaps between the data, a box plot is going to be the choice for data display. So we're going to complete the box plot. So they kind of told us the answer down here, right? All right, so the median of the data. So we're going to have to put this data in order. So 56, 66, 66, 72, 72, 75, 77, and 80. Right, so there should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So since we have that even number, that means we're going to have 2 that are in the middle. So the median would be 72. Okay, so we're going to mark that here. So 2, 4, 6, 8. So that means each one of these marks here are worth 2. So 72 would be the median. All right, so then the lower quartile, remember we have to include that now. So the lower quartile would be these 2 numbers, which are 66. And then my upper quartile, which would be this, which would be 75 and 77. So add them, divide by 2 would give me 76. So go over here. So 2, 4, 6. So that would be 66. And then 2, 4, 6 would be 76. So my box is going to look something like this. All right, and then we know that 80 is the largest and 56, so 2, 4, 6. So that would be what that box looks like. All right, so the interquartile range. So that means we are going to subtract these two, 76 and 66, which would be 10. And then the range would be 80 minus 56, which would give me 24. Okay, and then let me write this one down. So this is 76 minus 66. So quartiles, range, subtract them, so that's how you get that. All right, state one conclusion that can be drawn from the shape of data and the range, and one conclusion that can be drawn from the shape of data about the interquartile range. So the middle of the data falls between 10. Okay, because we got that from that interquartile range. All right, so we do have an outlier of 56, so that's why the range is a little bit higher. Or high, we put higher. I like higher better. Okay, so it's definitely not symmetrical because of that outlier. What else can we say? We can say not. And you can see that with that right here, that it's not symmetrical. All right, so that puts us to the check for understanding. So, state whether you used a measure of center. Once again, pause it. You know how to do it. Pause it and come back to it. All right, shape the spread to draw a conclusion. All right, so we need to know, draw one conclusion from the data, state whether you use measure of center or a fact of shape or spread. All right, so we're going to use a bunch of things. So we can use the range, right? And we know the range, it looks like it's 95 and 20, so 95 minus 20, so that gives me 75. We can do the interquartile range. So we know that that would be 70 minus 30, which gives me 40. So we know that students earned 65 or higher. Okay, because there's the median, right? And so we're going that way. And so we did that because of the median. Could see because of the median. Okay, definitely see that there's an outlier, right? Because the stem, that stem's longer, so we could also say that there is an outlier of 95. So that we know affects the data. All right, so let's look at this one. So what can we say about this one? I would say it's pretty symmetrical, right? Because data here, we do have some outliers. So I'm going to say symmetrical. We can say most people exercise between what, 4 and 6 hours? We have two outliers, so that would be 0 and 9. We could describe gaps, right? There's a gap between 0 and 3 and between 6 and 9. We can even say there is a peak at 5. So there's quite a things that we could say about that dot plot. Okay? All right, so that is that. So what I want you guys to do is I only want you guys to do the on your own number 3 and 4. And I am going to go over number 5 with you so that you can just put answers in the On Your On program. All right, so what statistical question might these data have been collected to answer? So it looks like the table summarizes the grade point averages for 12 students. So we're going to say GPA of 12 students. What might the box plot be a good way? Why might the box plot be a good way to display data about grade point averages? you can see how many of each one there is, right? So how many, what we call the frequency, right, of each GPA there is. All right, so we're going to do that box plot. So looks like we'll put them in order. So 2.0, 2.33, 2.67, 2.67, 3.0, 3.0, 3.0, 3.33, 3.67, 3.67, and then 4 and 4. All right, so 2.33, so we have 1. We need to do a box plot. My bad. All right, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So it looks like 2, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, so if it's even, so we're going to have 2. So 3 is the middle. And then we're going to use this, right? So 1, 2, 3. So it'd be 2 and 2. So 2.67. So there's that box. And then we're going to use this. So 3.67. Alright. And then my stem would be 4 and 2. Okay, so that's what that box plot should look like. Okay, so describe the distribution of the data. Pretty symmetrical. Wow. Okay, the range is 4 minus 2, which is 2. IQR, 3.67 minus 2.67, so that would be 1. So, sorry you couldn't see that, so that needs to be there. Write a statement using different measures of variability that could summarize the shape of the data. Well, we kind of just did that, right? All right, so mean, actually not mean, the median is 3, so we kind of did that. The IQR is 1. The range is 2. We could do the mean if we wanted to. So 4, 4, 2.67, 2.67. All right, so I get 34.34, and we said it was divided by 12, right? All right, so that is approximately 2.86. Okay? All right, so make sure you write those answers in. That way this on your own doesn't take you forever to complete. All right, have a great day.